Okay, this lesson's about the kinetic theory of matter, and we're going to start off by talking about the different states of matter and how the particles behave in those states, and then we're going to try and explain how gases create pressure. So here's just a reminder, hopefully, from some key stage 3 ideas of what the particles are like in solids and liquids and gases. So in a solid, the particles are close together and there are strong bonds between them, so they're in a fixed pattern. So this particle here can't fall off the side, it will stay in the same shape, okay, because there are strong bonds holding it on to the edges. Okay, in a liquid, the particles are still close together, but there are only weaker bonds between the particles. So here's my liquid, and if the box was taken away here, this particle could fall off the side. This is why liquids can change their shape, because the particles aren't very strongly attracted to the ones next to them. In a gas, the particles are far apart, there are no real bonds between them at all, and they're separate and they whiz around doing their own thing. Okay, the next thing you might want to know about is how we know that these particles actually exist. Okay, so a couple of pieces of evidence for how we know that these particles even exist and how scientists came to understand that this is what matter was made from. This experiment involves making some smoke, putting that smoke into a little cell. You cover the top over to keep the smoke in there. You light it up nice and brightly with this light down here, and then you can't see the individual pieces of smoke in there, but if you put them under a microscope, then you can see that there are individual little lumps of smoke which are just about big enough to see through the microscope, and they seem to jiggle around and move all by themselves in a fairly random way. So you ask yourself, well, how is it that a piece of smoke going in one direction can suddenly start moving in a slightly different direction? And it turns out that the explanation from this is that these little pieces of smoke are being hit by something. So here's our little piece of smoke. They seem to be just moving around on their own, but it turns out that in fact what's going on there is that the thing you can't see is the tiny particles, the air particles, okay, of oxygen and nitrogen, which are bumping into the smoke and knocking it in different directions. Okay, so although we can't see the particles, we can infer they're there. The first guy to do this actually did it with pollen. Okay, so Robert Brown knocked the pollen off a flower. He looked at the pollen underneath a microscope, he floated it on water, and he could see the same thing. The pollen grains seemed to move around by themselves. He didn't understand why this was. Okay, he came to the wrong conclusion, but he was the first person to observe it happening. And this was the evidence that eventually Einstein used in order to show people that particles existed, even though we couldn't see them. And then we need to move on from there to explain how a gas can create pressure, because it seems a bit unlikely, doesn't it, that these particles have got great big spaces between them, and yet their pressure can have quite a big effect. Okay, well, what happens is the particles come along, they hit the wall. In order for them to change direction, the wall has to create a force on the particle, and if the wall creates a force on the particle creates a force on the wall, just as if you threw a tennis ball against the wall, for example. So you might wonder why you can't feel all those little tiny collisions. Well, it turns out that the collisions individually create very, very small forces, but there are billions and billions of them happening on every tiny little bit of everything that the air is hitting every second, and they average out to create a pressure. Okay, we can model that in this kinetic theory model, where the ball bearings in here represent the particles in the air. Okay, so here's our explanation for this. So we've got, here are the particles in the gas, and 3 jobs that we're going to try to do. How does this diagram show the random motion of the particles? How does the gas create a pressure on the walls of the container? And then the explain one, the tricky part, what happens to the pressure on the walls as the temperature of the gas is increased? So here's the first part of our answer. You can see hopefully from the diagram that the motion is random in 2 ways. The length of the arrow, the velocity, shows you how fast the particles are moving and which way. So the length shows you the speed, and you'll notice there's a range of speeds. So an important thing to understand about gases is at a certain temperature there's still a big range of speeds of the different particles, and also they're moving in different directions. Okay, so there are two things which are different about these particles. One is how fast they're moving, and one is which direction they're moving in. Okay, the overall velocity of the gas is 0, so the gas won't all end up, the particles won't all end up at one end. Okay, they're moving around randomly, so on average they stay where they are. Okay, how does it create pressure on walls? Well, the particles move until they hit the wall, so this particle is going to come over here, eventually it's going to hit the wall. The collision between the particle and the wall creates a force, and there are lots and lots of collisions which overall creates a pressure. Okay, and then the trickiest bit, explain what happens to the pressure on the walls if the temperature of the gas is increased. Well, the energy of the particles comes from the kinetic energy of the particles in there. There are no forces between them, so there's no potential energy, and therefore the only way they can have more energy is to have more kinetic energy. If they've got more kinetic energy, that means they're moving faster, and if they're moving faster, that means when they hit the wall, they create a bigger force, and that increases the pressure. Of course, also, they're going to hit the wall more times every second because they're moving around faster. So there are actually two reasons why the pressure increases as the gas gets hotter. There are more collisions with the wall every second, and each collision creates a bigger force.